The English Channel has long separated Great Britain from mainland Europe. For centuries, people dreamed of a way to bridge this watery divide. In 1994, this ambitious dream became a reality with the completion of the Channel Tunnel, or Chunnel. The Chunnel is an underwater tunnel that connects Folkestone, England, to Coquelles, France. It stretches for over 31 miles, 50 kilometers, with 23 miles, 37 kilometers of that distance underwater. This makes it one of the longest underwater tunnels in the world. The Chunnel consists of 3 separate tunnels, 2 for rail traffic and 1 central tunnel for service and safety. The Chunnel has revolutionized travel between Great Britain and mainland Europe. Passengers can now journey from London to Paris in just over 2 hours by train. The English Channel may seem small on a map, but it presents a formidable barrier between Great Britain and continental Europe. The Channel is known for its strong currents, unpredictable weather, and often rough seas. These conditions made the prospect of building a fixed link between England and France incredibly challenging. One of the biggest challenges was the depth of the channel. The seabed is not flat, but rather a series of valleys and ridges. The deepest point along the tunnel route is over 250 feet below sea level. This meant that engineers had to dig through a variety of soil conditions, including chalk marl, which is a soft clay-like rock. Despite these challenges, engineers and construction workers were determined to overcome them. They knew that the Chunnel had the potential to transform travel between Great Britain and mainland Europe. Building a tunnel under the sea presented a unique set of engineering challenges. One of the most pressing was the need to prevent water from flooding the tunnel. Engineers had to develop innovative solutions to keep the seawater at bay. To address this challenge, engineers used a technique called pre-support. This involved injecting grout, a type of concrete, into the ground ahead of the tunnel boring machines. The grout solidified and created a waterproof barrier, preventing water from seeping into the tunnel. Another challenge was ventilation. Engineers designed a sophisticated ventilation system that used giant fans to circulate air through the tunnel. The engineering challenges of building the Chunnel were immense, but they were ultimately overcome through innovative thinking and meticulous planning. One of the most remarkable aspects of the Channel Tunnel project was the precision with which the 2 halves of the tunnel were bored to meet in the middle. Engineers used advanced surveying techniques and laser guidance systems to ensure that the tunnels were aligned correctly. The tunnel boring machines, TBMs, used to excavate the tunnel were marvels of engineering in their own right. These massive machines, each weighing over 1,000 tons, were equipped with rotating cutting heads that ground through the rock. The TBMs moved slowly but steadily, advancing a few meters each day. On December 1, 1990, the 2 halves of the service tunnel met. The breakthrough marked a major milestone in the project and a testament to the accuracy of the engineering work. The 2 halves of the running tunnels met in the following months. The precision with which the tunnels were aligned was astonishing, with a deviation of just a few centimeters. Safety was a paramount concern throughout the construction and operation of the Channel Tunnel. The confined space of the tunnel and the potential for fire and smoke presented unique challenges. Engineers implemented a range of safety measures to mitigate these risks. One of the most important safety features is the central service tunnel. This tunnel runs parallel to the 2 running tunnels and provides access for maintenance and emergency services. In the event of a fire or other incident, the service tunnel can be used to evacuate passengers and crew. The tunnel is equipped with a sophisticated fire detection and suppression system. Smoke detectors are located throughout the tunnel, and fire doors can be closed remotely to contain the spread of fire and smoke. The ventilation system is also designed to extract smoke from the tunnel. Unfortunately, in 1996 and 2008, serious fires occurred during the A trip in the Channel Tunnel. However, no other incident has occurred ever since. The tunnel boring machines, or TBMs, used to excavate the Channel Tunnel were marvels of modern engineering. These massive machines, nicknamed iron moles, were essential to the success of the project. The TBMs were custom-built for the Channel Tunnel project and were designed to cope with the specific challenges of tunneling under the English Channel. They were equipped with rotating cutting heads that ground through the chalk marl, a soft clay-like rock that makes up much of the seabed. The TBMs were operated by teams of skilled engineers and technicians. As they bored through the earth, they removed millions of tons of spoil, which was transported to the surface and used for land reclamation projects. The TBMs also installed the concrete lining segments that form the walls of the tunnel. These segments, each weighing several tons, were lifted into place by hydraulic arms and bolted together to create a watertight seal. The TBMs allowed engineers to excavate the tunnel quickly and efficiently, while minimizing the impact on the surrounding environment. The Channel Tunnel is not just a feat of engineering, it's a prime example of international collaboration. The project brought together thousands of workers from Britain and France, who worked side by side for over 6 years to make the dream of a tunnel under the sea a reality. The project was a joint venture between the British and French governments and was overseen by a binational commission. The workforce was made up of engineers, technicians, construction workers, and support staff from both countries. They learned to communicate and work together effectively, overcoming language barriers and cultural differences. The success of the Channel Tunnel project is a testament to the power of international collaboration. It shows that when countries work together, they can achieve extraordinary things. The Channel Tunnel has had a significant impact on trade and tourism between Britain and mainland Europe. It has made it easier and more efficient for businesses to transport goods across the Channel, and it has made Britain a more attractive destination for tourists from mainland Europe. Before the Chunnel, goods were transported between Britain and mainland Europe primarily by ferry or air. These methods were slow, expensive, and often unreliable, particularly during bad weather. The Chunnel provides a faster, more efficient, and more reliable way to transport goods, leading to a significant increase in cross-channel trade. Tourists can now travel from Paris to London in just over 2 hours by train, making it possible to visit Britain for a weekend or even a day trip. The increase in tourism has provided a significant boost to the British economy, creating jobs in the tourism, hospitality, and retail sectors. The Chunnel has helped to make Britain a more outward-looking and internationally connected country. While the Channel Tunnel has had many positive impacts, it has also raised environmental concerns. The construction and operation of the tunnel have had an impact on the marine environment and the surrounding ecosystems. One of the main concerns is the impact of noise and vibration from trains on marine life. The Channel Tunnel passes through a busy shipping lane, and there are concerns that the noise from trains could disturb marine mammals, such as dolphins and porpoises. Another concern is the potential for pollution from the tunnel. The tunnel is equipped with systems to prevent the discharge of pollutants into the marine environment, but there is always a risk of accidental spills or leaks. To address these concerns, the operators of the Channel Tunnel have implemented a number of environmental management measures. These include monitoring noise and vibration levels, managing waste and pollution, and working to minimize the impact of the tunnel on marine life. There is no doubt that the Channel Tunnel is a marvel of modern engineering and will continue to serve as the fastest way to travel between the countries for generations to come. Subscribe for more.